Very good morning to all. Standard 11 Commerce, subject statistic, and chapter number 4, measures of dispersion. In that particular thing that we learn about range and standard deviation. Now we will discuss average deviation. Okay, so third one, that is average. Average deviation that we have to learn over here. The range and quartile deviation are two measures of dispersion in which all observation of data are not used and do not do to show the variation of the observations from any averages. This limitation can be overcome by the measures of dispersion in which all observations from any average, all observations are considered and variations of each observation from the average is known as into account. Those requirements are fulfilled by the average deviations. It is not also known as mean deviations. So instead of average, we can also take mean deviation because similar word is there. The difference between value of observation and its mean is known as deviation. Those deviations can be negative, 0 or positive. Three ways there. Either it is negative, either it is positive, or either it is 0. The sum of all the such observation is 0, seen in chapter number 3. To overcome this situation, the absolute value of those deviations are taken. It means that the negative sign of the negative observations are ignored and the measures are based on absolute deviation of the data. It means that minus sign not considered over here. That's why in this particular example, in this particular formula, they are using modules. And as below, what do you mean by modules? Either plus or minus. When you convert module into simple term, it's always plus. Okay? So here, thus the mean of the absolute mean deviation of the observation of a data from its mean is called mean deviation, and it is denoted by MD. Mean deviation is equal to MD. Okay? Next one. The relative measures of mean deviation obtained by dividing MD by the mean, that is MD divided by X, that is coefficient of MD is equal to MD divided by X bar. Okay, so same way range and coefficient of range, then deviations, coefficient of standard deviation, quartile deviation, that is Q3 and Q1 that we have to use. Same here in this particular thing, mean deviation MD and coefficient of MD is equal to MD divided by X bar. What do you mean by MD? That we have to learn over here. So here coefficient of MD is equal to MD divided by X bar. And now here we have to learn that what do you mean by mean deviations. Okay. So let's see. Method of computing mean deviation. We shall now discuss the method of formulate the computing mean deviation in ungroup or row data. So when ungroup or row data is there, MD is equal to sigma X minus X bar upon N. Because in module that we have to take, because we have to take only plus sign, only plus things, and that's why here we have to take in module. Okay. Next one, if it is discrete frequency distribution, so as we know, what do you mean by X bar? So X bar is equal to sigma X upon N that we used in third chapter also. See, third chapter is connected with this chapter. If you know third chapter, then it is easy to understand fourth and fifth chapter also. Okay. So here, next one, that is group data. So if group data is there, only one change, same formula is there, only one change. Here sigma Fi, because in group data is there, definitely two types of information is there. Number one, that is X, second one, that is number of N, that is frequency. So whatever frequency is there, that we have to add over here. So sigma Fi in module X minus X bar divided by N. So this formula that we have to use when we are calculating mean deviation in group data. Whether it is a discrete frequency distribution or continuous frequency distribution, formula will not be changed. Okay. Same here. Value of x, so fi xi upon m. So same way, if group data is that md is different, sigma x bar also different. On the basis of this information, we have to take that what should be adopted. Okay. Next one, in continuous frequency distribution. So same way in continuous frequency distribution also we have to take the examples. Okay. So this one that we will understand with the help of illustration and examples. So here let us calculate example number 8. Okay. So what is example number 8? Let's see. The measurement of height in kg of 8 students of class of a school are given below. So heights is given. Let's see. Assume x 46, 58, 60, 43, 75, 66, 51 and 81. So definitely number of n is equal to 8. Now what happened? Find out the mean deviation and coefficient of mean deviation. So first of all we have to write. What we have to write? Formula. So what is the formula? So here mean deviation. So mean deviation MD is equal to raw data is there, no F is given. So sigma in module x minus x bar upon m. Okay. And here coefficient of MD is equal to MD divided by x bar. Okay. So here first of all we have to take x. So here that we have to take x. Okay. So 46, 58, 60, 43, 75, 66, 51 and 81. So number of n is equal to 8. So as we know, with the help of this data, what we have to do? First of all, we have to find out x bar. So how we can find out x bar? So here sigma x bar upon n. This is the formula of x bar. So sigma n, then we have to do summation of all. So definitely answer is 480. So 480 is there. So here 480 divided by 8. Answer is 60. So this is mean. Now what is our formula? X minus x bar. Okay. So we have to take over here, that is x minus x bar, and then whatever value is there, that we have to convert. In module. So in module x minus x bar. Okay. So x bar is equal to 60. So here we have to write down 60. So it will be so easy to understand. Next 46 minus 16. So 14. Okay. Then after minus 14, 58 minus 60 minus 2, 60 minus 60 0, 43 minus 60 17. Yes, minus 70, 75 minus 16 15, 66 minus 60 6, 51 minus 60 minus 9 and 81 minus 60, that is 21. Okay. So this is a module. Now we have to convert this in modules. So plus become plus, minus become also plus. So 14, 2, 0, 17, 15, 6, 9 and 21. Because when we convert module, all sign become plus. Now what we have to do? Sigma x minus x bar in module. Sigma, that means summations. So total is 84. So simple. Now we have to put total 84. 84 divided by 60. Sorry, number of n. So number of n is equal to 8. So 84 divided by 8. Okay. So here then we can use 84 divided by 8. That is 10.5. So here that answer is 10.5. So this is a mean deviations. Okay, and this is the answer of mean deviation. Now second one, what we have to find out? Coefficient of mean deviation. So what is the formula? MD divided by x bar. MD is equal to 10.5, x bar is equal to 60. So 10.5 divided by 60, 0.175. Third digit is 5, and if third digit is 5 or more than 5, what we have to do? We have to change one digit. So 0.80. So this will be your answer. Okay? How we can find out? First of all, whatever information given, we have to find out x bar. On the basis of x bar, we have to find out x minus x bar, and then we have to convert x minus x bar into module. And when we convert that in module, definitely all the sign that we can see in plus. X bar that we have to find out sigma x upon n, and MD is equal to sigma in module x minus x bar upon n, and coefficient of MD is equal to MD upon x bar, that is 10.5 divided by 60. 60 is a x bar that we have to take over here. Our answer will be 0.18. Let's see.